That sudden crack after a lightning flash is not clouds banging together. It is air being violently shocked by electricity, and it happens faster than you can blink. When a thunderstorm builds, warm, moist air rises into a tall cumulonimbus cloud. Inside that cloud, water drops, ice crystals, and soft hail collide again and again. Those collisions separate electric charge. Positive charge gathers higher in the cloud, while negative charge builds lower down. Eventually, the air can no longer act as an insulator. The electric field becomes strong enough to force a path through the atmosphere, and lightning begins. A faint stepped leader moves down from the cloud, searching for the easiest route. When it connects with an upward streamer from the ground or another object, a powerful return stroke races back up the channel. That return stroke is the bright flash we see, and it carries enormous electrical energy through a very narrow path of air. In a few millionths of a second, the air around that path can be heated to about 30,000 degrees Celsius. That is roughly 5 times hotter than the surface of the sun. At that temperature, the air becomes a plasma, with electrons torn away from molecules. The heating is so sudden that the air cannot expand gently. Instead, pressure surges outward explosively from the lightning channel. At first, that expanding pressure wave moves faster than the speed of sound. It is a real shock wave, much like a tiny sonic boom stretched along the lightning path. As it travels away from the channel, it loses energy and becomes the sound wave we hear as thunder. If the strike is very close, the sound reaches you as a sharp crack, because the shock wave has not been softened much by distance. A little farther away, it becomes a loud boom. At greater distances, thunder often rolls and rumbles. That is because a lightning channel is long and branched. Sound from the nearest part reaches you first, while sound from higher or more distant branches arrives later. Clouds, hills, buildings, and layers of air also reflect and scatter the sound, stretching one flash into several seconds of rumble. In open country, thunder may sound clean and distinct. In cities, valleys, or tropical humid air, it can echo, soften, and deepen. You can use thunder to judge how far away lightning is. Light arrives almost instantly, but sound travels much more slowly, at about 343 meters per second. Count the seconds between the flash and the thunder. In metric terms, divide that number by 3 to estimate the distance in kilometers. A 15-second gap means the lightning was about 5 kilometers away. Safety matters, because thunder means lightning is close enough to be a threat. If the time between flash and bang is 30 seconds or less, the storm is within about 10 kilometers. Get inside a solid building or a hard-topped vehicle straight away. Then wait 30 minutes after the last thunder before going back outside. Thunder is the atmosphere telling you that lightning has already found a path. Hear it, respect it, and move to shelter.